So even though 90% has been transmitted, so 90% during the channel transmission, during the transmission, it is it will face definitely some noise distortion, okay, by which the signal will deteriorate or signal will destroy it. So in that time 80% some information will be lost. And after that signal at receiver side, whether it is such a amount, whether it is capable to detect 80% or 70% or 60% of amount information, that we have to maybe it is having a very low SNR, means high SNR. If it is there, suppose that time we can say okay, it will receive even a small amount, you can detect this signal even at a low power or a low value as well. But if it is having a low SNR, then that time it is not possible to achieve such value to detect that value. So sufficient amount of power should be transmitted so that even after distortions, after noises, it can receiver can receive sufficient amount of energy signal in order to retain full message signal. Okay, so by this, for this only link budgeting will be done. Now the Frisch transmission equation is also there, which is received power at the receiver side, means whatever the minimum received power is required at the receiver side, that we can calculate with the help of uh, transmitted power multiplied by transmitted gain multiplied by the receiver side gain multiplied by lambda divided by 4 pi r to the square. Okay, this is all. PT means transmitted power, transmitted antenna gain, receiver antenna gain, GR, GT, and PT, and PR is the received power gain. Okay, received receiver power, and it is obviously will define in the watt only. Okay, now power density can also be defined as power density is power density, how much signal strength it has to be there, and signal strength for that signal and power receiver minimum power should be given. Okay, power density can be calculated as PD is equals to PTGT divided by 4 pi r square, which is also given as watt only. Okay, now this Smith chart, yeah, this is also very very important. Invented in 1939 only, it means almost 90 years back, 1995 years back, and it is developed by Phillips H. Smith. That's why it is given as name as Smith chart. Okay, now what is the benefit of Smith chart? Evaluating magnitude, phase, input impedance, and return loss, etc. That I've already told during the S parameter session. Okay, then further evaluating the input output transfer function also. This can also be done in the case of Smith chart. Now plotting complex impedance versus frequency, this also can be used. And further, it is having a short and open will be there. Short will be there, okay, and between the load will be there and open will be there, okay, which is R equals to infinity, and in between R equal to 50 ohm will be there, which is a midpoint of this center of this Smith chart. Okay, this is nothing but the resistance and reactance circle. Okay, and conductance circle we can also place so that it will have a complete image for the Smith chart. But anyway, it is not a complete chart for the Smith chart. We can compute numerous parameters: gain, S11, VSWR, impedance, reflection coefficient, so many things we can. Okay, so why we can use Smith chart if polar plot is already available? This can be your one of your homework as well. Anyway, if you are not getting, then I will tell in my next lecture. Okay, now quality factor. As you might remember that I have already discussed that what will be the all will be the losses, because of losses, which even though we are getting we are observing ideal values VSWR equal to 1, S1 is equals to higher than minus 40, minus 30, like that. So then time also this, because of the conduct some losses, our results will not be ideally at all. Okay, so these can be the quality factor which will depends upon the losses, which is QT. QT will also have a 1 divided by, it is a sum of the some losses, QRAT, QC, QD, and QSW, which is surface wave loss, and quality factor is dielectric losses, quality factor due to the conduction losses, quality factor due to the radiation losses. Okay, this losses we'll see in the next module, which is our third module, antenna feeds and losses. Okay, and further we'll continue the next lecture in the next session. Next session we'll start our the next module, which is antenna feeds and losses. So before starting also, I will give a brief description about that module. Okay, thank you.